In this video, I'm going to talk about piecewise defined functions. So a piecewise defined function is just exactly what it sounds like. It's a function that's broken down into different pieces. So for different x values, there's going to be different rules. The actual definition of piecewise defined function is a function that is defined using different rules for different non-overlapping. The pieces can't be overlapping at all. Intervals, and that's just a fancy way of saying ranges of x of its domain. And domain is just a fancy way of saying all the x values that are defined for this function. If I look at this graph right here, this is an example of a piecewise function. So this doesn't look exactly like something we've seen before. Well, it looks like something I've seen before, but it doesn't look like something you've seen before. However, if we break it down into pieces, it looks exactly like something you've seen a million times. If I look at the left part of this graph from where x is negative infinity to where x is 3, that's a piece of a line. It's an increasing line. And then if I look from the x values that are greater than 3, so I look at the right side of this graph, that's just a piece of a downwards sloping line. I have two pieces of two different lines brought together to be one function, and we call that function a piecewise function. To describe this graph, I'm going to break it down into the different pieces. So I'm going to start with the left-hand side. I have this function is increasing for the red piece. It's an increasing linear function. For the values of x from negative infinity to positive 3. So for x values from negative infinity to positive 3 with a slope, because that's how I define a line, with slope and y-intercept. So it has a slope of, from one point to the next, I'm going up one to the right one, which means my slope is 1 over 1, or just 1. So with a slope of 1, and y-intercept of, well, the y-intercept is already there for me, it's negative 2. So a y-intercept of negative 2. So if I wanted to write a rule for this piece, I would say the rule for x values, I know I'm using y equals mx plus b, because it's a piece of a line, and I'm subbing in for m, I'm subbing in 1, and for the b, I'm subbing in negative 2. So I have y is equal to x minus 2. And that's for x values that are less than 3. So that takes care of my red piece. Then talking about the blue piece, this piecewise function is, for the blue piece, a decreasing linear function again, because it's part of a line. For x values from, I'm starting at 3 and going to positive infinity. So from 3 to positive infinity with a slope of, I'm going to have a slope from one point to the next. I'm going down 2 to the right one, down 2 to the right one. So that's negative 2 over 1, which is just negative 2. And a y-intercept of, I don't see it, it's not immediately on the graph, but I can easily find it out by using the slope and going backwards. So I'm going up 2 to the left one, up 2 to the left one, up 2 to the left one, and I'm going to hit 7. So I know my y-intercept is 7. So I'm going to, 7. And if I want to come up with a rule for the blue piece, I would use y equals mx plus b. And then I would sub in m is negative 2 and b is 7. So I have y is equal to negative 2x plus 7 for x values that are this point here is shaded. It's included in this function, so I have to include 3 in one of my pieces, and since I didn't include it for the red one, I'm going to include it for the blue one by saying for x values that are greater than or equal to 3. So those are my 2 pieces for the different intervals that I have. X is less than 3 is an interval, and x is greater than or equal to 3 is an interval. Now I want to talk about how do I know that this graph is a function? Well, if you don't remember from Algebra 1, the way that I know that something is a function is if for each x value, there's only one y value. And that is true for this graph. So I know because for each x value, for each input, there's only one output. And I can see this in any graph by using the vertical line test, which I think you've heard about before. But the vertical line test, and you don't have to draw this on your paper. Actually, don't draw it because then you won't be able to see the graph. But the vertical line test says that if I can draw a vertical line in the graph and it intersects the graph in 2 places, then that graph is not a function. However, if I could draw an infinite amount of vertical lines for this case, and I would only intersect the graph in one place. That tells me that for every x value, I only have one y value. So I can also say that this passes the vertical line test. An example of something that wouldn't be a function is a sideways parabola. So if I drew a sideways parabola here, I would see that for x is 0, I would have both the answer 3 for y, and I would also have y is equal to 5.5. I have 2 different y's there for one x, so I know it's not a function, so that would not be a function. For number 3, I want to graph these 2 different rules on the same coordinate plane. The first rule that I have is y is equal to x squared minus 3 for x values that are less than or equal to 0. The second rule that I have is y is equal to 1/4 x plus 1 for x is greater than 0. I'm going to graph the red piece first, so I'm going to look at the red piece first. Before I actually graph it, I want to decide what is it going to look like. I know it's going to be a piece of something. What is it going to be a piece of? Well, I have the rule y is equal to x squared minus 3, and I know if I see x to the second power in my equation, I have a quadratic equation, which means the shape that I'm going to have on the graph is a parabola. And if you forget what a parabola looks like, it's going to be a U shape. Then after I decide what shape this graph is going to look like, that's going to help me to do my next step, which is to make a table. So if ever you forget how to graph something, you can always pick values for x, plug them in, and see what you get for y. And that's what we're going to do in this case. I'm going to make a table here, an xy table, and I'm going to pick values for x and see what I get for y. Because I have a parabola, I'm going to use at least 3 points. The first x value that you absolutely need to choose for your table is the one that starts the interval. So the interval that I have here is x is less than or equal to 0. That means my piece starts at 0. I need to include where the piece starts and where the piece ends. For most pieces that you have in piecewise functions, they're going to end on negative infinity or positive infinity. So you obviously can't pick that as a value for x because it's not a number, it's a concept. But you do need to make sure if you have a number start, you need to make sure that point is included. So I'm picking x is 0 to start, and then I'm going to see what do I get for y. Well, when I plug in x is 0 into this equation, I have y is equal to 0 squared minus 3. That gives me negative 3. For the next x value that I pick, I want it could be anything I want as long as it's less than or equal to 0. So the next one I'm going to pick is negative 1, since that's the next whole number that's less than or equal to 0. I have y is equal to negative 1 squared minus 3, which gives me negative 1 squared is 1, 1 minus 3 is negative 2. And then I'm going to pick x is negative 2. And I'm going to do y is equal to negative 2 squared minus 3. Negative 2 squared is 4, 4 minus 3 is 1. So now I have these points. before I graph them, I want to look at the starting point, so 0, -3, and I want to decide, is that point going to be included or not? So I look at my interval. Is that x value included or is that x value not included? Well, I have x is less than or equal to 0, which means x is equal to 0 is included. So if x is equal to 0 is included, then I know the point where x is 0 is also included. So this point is going to be included, and I'm going to indicate it's included by putting a shaded dot on it. So on 0, -3, I put a shaded dot. The next point I have is -1, -2. So I'm going to put a dot on -1, -2. That's obviously included. And then I have -2, 1. So -2, 1 right here. You can see that curves like a piece of a parabola would, because a parabola is curved. I'm not going to be making a full parabola here. I'm not doing to the right. Do not draw to the right. You're only drawing to the left. Only the x values that are less than 0 are included in this piece, like that. All right, then I'm going to talk about my next piece. So the next piece is y is equal to, y is equal to 1/4 x plus 1. I know that that's going to look like a line. It's going to look like a piece of a line. And for a line, if I know it's a line already, I only need 2 points. So I'm going to make a table with just 2 points. The first x value that I absolutely need to pick is where my interval starts. I have x is greater than 0, which means I'm going to start, the first thing I'm going to pick is x is 0. I'm going to plug it into my equation. I have y is equal to 1/4 times 0 plus 1, which gives me 0 plus 1, which is 1. The next x value that I'm going to pick is something that's greater than 0. I could pick whatever I want. I could pick 1, but then I'd get a fraction, and I don't like fractions, so I'm not going to pick 1. I'm going to pick something that's divisible by 4 so that I could get rid of that fraction, and I'm going to get a whole number answer. The next value that's greater than 0 that is divisible by 4 is 4, so I'm going to pick x is 4. I'm going to do y is equal to 1/4 times 4 plus 1 to find what my y is. I have 1/4 times 4 is 1, 1 plus 1 is 2. And then I have those 2 points. Now looking at 0, 1, I want to talk about, because that's the starting point of this piece, is that included or is it not included? And when I look at my interval, I have x is greater than 0, so x is equal to 0 is not included, which means the point where x is 0 is not included. Everything just a little bit greater than, every x value that's just a little bit greater than 0 is included, which is why on this point on the graph, just like I would on a number line, I'm going to put an open circle on 0, 1 to indicate that everything to the right is included, even though that is not. So I'm going to put the next point, 4, 2, right here, and then I'm going to connect these two in a linear fashion. All right, and that's my piecewise function. I want to describe this graph as completely as possible. And then I want to talk about how I know that this graph is a function, and it's not just because I said it a million times. So the first thing I'm going to do is talk about the red piece. I have the red piece tells me that I have as I read from left to right, is a decreasing, and the adjective for parabola is parabolic. So it's a decreasing parabolic function for x values from, I'm going from -infinity to stopping at 0. Then I have the second piece tells me that this piecewise function is increasing as I read left to right. It's an increasing linear function because it's a piece of a line for x values from, I'm starting at 0 and I'm going to +infinity. The reason I know that this graph is a function is because I can't draw a vertical line that intersects in two different places. So even at where x is equal to 0, it looks like I intersect in two different places, but I'm not actually intersecting in the blue piece. When x is equal to 0, the only answer is 4. This open circle is not a shaded part on my graph. So this is a function because it passes the vertical line test. So it equals a function. For number 5, I want to fill out the table of values and graph the function. The function that I'm given is g of x is equal to negative 2x minus 2 if x is less than negative 1, or g of x is equal to x plus 3 if x is greater than or equal to negative 1. Before I do anything here, I want to say g of x is just a fancy way of saying y. So my output is going to be equal to this expression or this expression, depending on which x values I have. So if I'm looking at the first part, or the first piece of this rule, is going to be negative 2x minus 2 if x is less than negative 1. The second piece is x plus 3 if x is greater than or equal to negative 1. Which means, for my red piece, I'm using the rule y is equal to negative 2x minus 2. And for my blue piece, for those x values, I'm using the rule y is equal to x plus 3. Both of these are going to be pieces of a line. So both of these, when I draw them on my graph, should look like pieces of a line. To determine which equation I'm going to use, given the values in this table, I'm going to look at which interval they fall into. So for negative 4, I know that that is going to be less than negative 1, which means it falls into the red piece. So I'm going to use the red equation for it. Negative 3 falls also into that interval, x is less than negative 1. Since negative 3 is less than negative 1, I'm using the red equation again. For negative 2, I know that's less than negative 1 as well, so I'm using the red equation as well. I know if I can use the red equation, I don't even need to look at the blue equation, because for piecewise functions, they should not be overlapping. It's only going to be included in one of the pieces. For negative 1, I know negative 1 is included in the blue interval because x is greater than or equal to negative 1. So x is equal to negative 1 is included in that blue piece. X is equal to 0. 0 is greater than negative 1, so it's included in the blue piece. So is 1, and so is 2. For negative 4, I'm going to plug it into the red piece equation. I have y is equal to negative 2 times the negative 4 minus 2. Negative 2 times negative 4 is 8. 8 minus 2 gives me 6. For negative 3, I'm plugging it into that red equation again. So I have y is equal to negative 2 times negative 3 minus 2. That gives me negative 2 times negative 3 is 6. 6 minus 2 is 4. For negative 2, I have y is equal to negative 2 times negative 2 minus 2. Negative 2 times negative 2 is 4. 4 minus 2 is 2. For the blue, for negative 1, I'm switching to the blue equation. So I have y is equal to negative 1 plus 3, which gives me 2. For 0, I have y is equal to 0 plus 3, which gives me 3. For 1, I have y is equal to 1 plus 3, which gives me 4. And then 2, I have y is equal to 2 plus 3, which gives me 5. And then I'm just going to plot these pieces on my graph. So I'm going to start with the blue piece. I have negative 1 comma 2. I know that is included since x is equal to negative 1 is included in this interval. So I'm going to put this is included. I'm going to put a shaded dot on that piece. So I have negative 1 and 2. And I'm putting a shaded dot. Then I have 0 and 3, 1 and 4, 2 and 5, and then I'm connecting these. And that's a piece of a line. For the red piece, I'm going to start at negative 4 comma 6. Negative 4 comma 6, negative 3 comma 4, negative 2 comma 2, and then I did not include, negative 2 is not the starting point of my piece, negative 1 is, so I need to see what would y be if x was negative 1 if I use this equation, so I could see where my piece would start. I have y is equal to negative 2 times negative 1 minus 2 for x is equal to negative 1 for the red equation. I have that's 2 minus 2, which is 0. So I have the point negative 1 comma 0 that I'm going to graph. And that is not going to be included, but I need to include it because this is the starting point of my piece. And I know everything just a little bit less than negative 1 is included. So I'm going to put on -1, 0, I'm going to put a open circle on that. And then I'm going to shade everything to the left. I'm going to connect to the left like that. And those are my two pieces of this piecewise function. This function given here is g of x, and I want to write the domain and range of g of x in inequalities, and I also want to write it in interval notation. So those are two different ways of writing the domain and range. We're going to take a little bit of notes here to remind ourselves what domain and range mean. So I have domain and range. I'm going to talk about inequalities, the way to write them using inequalities, and the way to write them using interval notation. All right, so domain, as a reminder, it just means all included x values. So all included x values. And range means all included y values. If I wanted to write the domain in terms of inequalities, I would write the lowest x value is less than x, which is less than the highest x value. I could also write less than or equal to, depending on if the highest value and lowest value were included or not. For range, I write the lowest y value is less than y, which is less than the highest y value. So same thing, just y instead. Again, I could also write less than or equal to for this compound inequality. For interval notation, I would just write that lowest x value and that highest x value as a point. So I would write the left coordinate in the point would be the lowest x value. And then I do comma the highest x value and close the point. For range, I would do lowest y value, comma the highest y value, and then close the point. Now there are two different ways that you can write these points. You could either use parentheses or you could use brackets. For when you use parentheses, that you're going to use parentheses when it's included. So that's when it's not included. So when that highest value or lowest value is not included. Then you're going to use brackets for when they are included. If I look at this graph for g of x, so this is g of x, I want to decide what's the domain and what's the range. The notation that we're going to use in this class is interval notation. So we're going to use interval notation in this class only, but we'll go over the inequality because that's the one that you used before. So first of all, for the inequality, I would write, well, what's my lowest x value here? My lowest x value is, this line goes on and on and on forever. So my lowest x value is going to be -infinity. So I'm going to write -infinity is less than x, which is less than what's my highest value. It's, this line goes on and on forever, so it's going to be +infinity. If I wanted to write that in interval notation, I would write -infinity, and I would put a parentheses on it because you can't include -infinity or positive infinity because they're concepts, not actual numbers. And then I would put comma, my highest value is +infinity. And again, I'm putting parentheses on that. You should always have parentheses, not brackets, on your infinities. For range, the interval notation, I would do the lowest y value, which is right here. The lowest y value is 0, so that would be 0. Is that included? No, it's not because it's an open circle, so I'm putting parentheses on that. Comma, the highest y value, and since this goes on and on forever, I know the highest value is going to be infinity, and I'm going to put parentheses on that because it's infinity and can't be included. If I write the inequality, it would be 0 is less than y, which is less than positive infinity. And that's how I would write my range. I want you guys to try 7 on your own.